Alright, good day to everyone. Today we will be considering the sample problems in Module 2 of Geotechnical Engineering. So next, from the previous problem, determine the weight of water in kilonewton to be added per cubic meter of soil for letter A, 90% degree of saturation, letter B, 100% degree of saturation. So this problem is just a continuation of the second problem that we solved a while back. So we are to determine the additional weight of water, and we will be considering a sample of soil which is 1 cubic meter only. So determine the weight of water in kilonewton to be added per cubic meter of soil. So note that in addition of water, there will be no change in the total volume of soil. The soil ay hindi magbabago, only the volume of water in voids. Okay, so the idea is, initially, kanina, we were able to solve the degree of saturation to be 87.2%. Now, of a certain volume, a certain weight of water has been added to this that increase the degree of saturation to 90% degree. So that is what is being required. Ilan yung weight of water na dinagdag dito para maging 90% yung degree of saturation. Okay, so what we are going to do is to solve the weight of water for this particular situation. When S is equal to 87.2%, we will be solving the weight of water on this, and then we will also be solving the weight of water if it is 90% degree of saturation. And then from there, we subtract the weight of water on this 90% degree of saturation. We subtract it to the weight of water in this 87.2 degree of saturation. Then we can get the additional weight of water. Alright, so let's start. So the first is, let us solve for the weight of water considering S is equal to 87.2%, since ito yung initial na condition or situation ng soil sample natin. So we were able to solve the moist unit weight a while back, and we know that moist unit weight is equal to the weight over volume. So ang i-consider lang natin na volume ay 1 cubic meter. So from there, we can solve for the weight of the soil. So that becomes 20.6 kilonewton per cubic meter times the volume, which is 1 cubic meter. Cubic meter and cubic meter will cancel out, and the weight, initial weight, is 20.6 kilonewton. So we will be calling this initial weight, or the weight in terms of degree of saturation is equal to 87.2%. Alright, so we already had the weight of water on this. Next is to solve the weight of water if the degree of saturation is 90%. Okay, so this time, considering 90% degree of saturation, by the way, we will be presenting two methods. Method 1 is using the unit weight of soil. So let us first solve the moist unit weight of the soil considering now the 90% degree of saturation. So substituting this equation, that becomes the specific gravity 2.74. This is given in the problem a while back, and then plus the void ratio. The void ratio is, we were able to solve this. And then the degree of saturation, we will now be using 90%. So that is 0.9 times the unit weight of water divided by 1 plus the void ratio. So the moist unit weight, considering 90% degree of saturation, is 20.693 kilonewton per cubic meter. So we also know that unit weight is simply the weight divided by volume. So ang i-consider lang natin dito na volume ay 1 cubic meter. So therefore, we can now solve the new weight of water for 90% degree of saturation. So weight of water is equal to 20.693 kilonewton divided by cubic meter times the volume, which is 1 cubic meter. Cubic meter and cubic meter will cancel out. we have now the weight of water, which is 20.693 kilonewton. So again, this one is if the degree of saturation is 90%. So since we already solved that one, the weight of water that is added is simply the weight of water in the 90-degree saturation less the weight of water in the 87 point something, or I think 82.7 degree of saturation, or the initial weight of water. So substituting, that is 20.693 kilonewton minus 20.6 kilonewton. So the weight of water added is 0.93 kilonewton per cubic meter. The next method is using the unit volume of water, or that is simply the volume of water is equal to the degree of saturation multiplied by the porosity multiplied by the volume. So initially, we can solve the volume of water. Since we know the degree of saturation, we solve the porosity, and then we will only be considering 1 cubic meter of volume. So substituting, our initial volume of water is equal to the degree of saturation, which is 0.872, multiplied by porosity 0.343, and then multiplied by the volume 1 cubic meter. So again, I will just repeat, no, kung nalilito pa rin kayo kung saan kinuha itong value ng S at saka N, ito ay nakuha natin when we solve the second problem. So remember that this is just a continuation of that second problem. Okay? So itong value na to ay na-solve na natin, and then we will be considering only 1 cubic meter of soil. So initially, we have a volume of water is equal to 0.299 cubic meter. So this time, we are now considering the 90% degree saturation. So volume of water, let's denote that as nu, since yung kanina is initial. So this is nu. The new volume of water is equal to same equation, degree of saturation multiplied by porosity multiplied by volume of water, but this time, yung degree of saturation natin ay 90%. So substituting, that becomes now 0.9 times porosity 0.343 times the volume, which is 1 cubic meter. So volume of water is equal to 0.308 cubic meter. So we now have the initial volume of water, and the initial volume of water is 0.299 cubic meter when the degree of saturation is 87.2%. Ngayon, nagdagdag tayo ng tubig, kaya yung degree of saturation ay naging 90%. Ngayon, ang hinahanap natin is ilan, or what is the weight of the water that has been added per cubic meter. So let's continue. The volume of the water added is simply the new volume minus the initial volume. So substituting, that becomes now 0.308 minus the initial 0.299 cubic meter. So the volume of water that has been added is 9.493 times 10 raised to negative 3 cubic meter. But since what is being asked is the weight, so let us continue the solution, because we only arrived at volume, and what is being required is the weight. So from the unit weight of water, we know that unit weight of water, or unit weight, is simply weight divided by volume. And since we are talking about water, unit weight of water is equal to the weight of water divided by the volume of water. So from here, our unit weight of water is 9.81. The weight of water is this one. I mean, the volume of water, I should say, the volume of water is yung na-solve natin. And from there, malalaman na natin yung weight of water. So substituting, that becomes 9.81 is equal to weight of water divided by 9.493 times 10 raised to negative 3 cubic meter. Simplifying, the weight of water that has been added is 0.93 kilonewton. So the same value that we had solved in the first method. So again, sa presentation ng solution, you can just choose any of the method that is more convenient to you, and then the other one is just for your checking.